So this is the physical science paper for 2015, and this is question 6. Two stationary ice skaters push off against each other. Skater 1 has a mass of 60 kilograms, and skater 2 has a mass of 45 kilograms. Assume this ice is frictionless. On diagram A below, push approximately to scale the horizontal forces on each skater at the instant they push off against each other. Justify your answer by an appropriate law of physics. A numerical answer is not required. So what we have here is this person is pushing against that one, and that one is pushing against that one. Now, the force that skater 1 is pushing on skater 2 is going to be the same as the force against skater 2 pushing against skater 1. So the force of 1 on 2 is going to be the same. It should be approximately the same. Force of 2 on 1 is Newton's third law states that justify your answer by using appropriate law of physics. So what's happening there is the equal in magnitude states that forces are equal in magnitude, opposite in direction. Okay, what are the horizontal forces on each skater after they have moved apart, shown in diagram B? Justify your answer using the horizontal forces. Well, as they're pushed apart in that, then what's going to be happening is that they're going to be moving at constant velocities. Both moving at constant velocity. Therefore, Newton's first law states there are no external unbalanced forces. Therefore, no horizontal forces. There are no horizontal forces. This one's moving back that way, and that one's moving back that way. There are no horizontal forces at play. Turn over, and we'll have a look at question 6, part C. On the diagram below, draw approximately to scale the vertical forces on skater 1, including numerical values. Okay, well, what did skater 1, what was the mass of that? 60 kilograms. Okay, well, in this case, also, you can tell that this skater is not accelerating in either direction. So the force down, force of gravity, is going to be equal to the force of the normal force. And what is the force of gravity going to be equal to? It's going to be equal to the mass times g. It's equal to 60.0 multiplied by 9.81. Bring out the trusty calculator. 60.0 multiplied 9.81. 588 or 589. 589 newtons down. So it's going to be 589 newtons up. The velocity of skater 2 after they push off is 0.375 meters per second to the right. What is the velocity of skater 1? Okay, well, we have them here. the velocity of skater 2 after they push off is velocity 2 is equal to 0.375 meters per second minus 1 in that direction, and mass 2 is equal to 45 kilograms. V2 will equal V1 will equal, we don't know what that one is, but we do know the mass, which is equal to 60.0 kilograms. Okay, now due to the law of conservation of momentum, because they were pushing each other off, and they were initially at 0, then their initial velocity, let's see, m1u1 plus m2u2 equals m1v1 plus m2v2. Cons moment. Now, what that means is all of this, because they were stationary, that's going to be equal to 0. So it's equal to 60.0 times V1 plus 45 times 0.375. So what do we have here? Back to the trusty calculator. So what we have here is 45, working out this part here first. 45 multiplied 0.375 equals minus, let's subtract this one over to this side, minus 60.0 times V1 is equal to this number here, which is 16.875. So therefore, V1 equals 16.875 divided by minus 60, which equals, divided by negative 60, equals negative 0.28 meters per second minus 1. So what that means is skater 1 travelling opposite direction at 0.28 meters per second minus 1.